Okay. I'll teach you guys how to declare your struct, the best and faster way to do it without wasting your time. It's just straightforward. Okay. Teach you guys how to create your nodes. Let's create the list. Okay. Yeah. How to add items to the list. I'll teach you guys how to delete some items from the list. And I likely for this time, I'd like to teach you guys how to add an item to an existing list at a particular position. Okay. I think that's what you guys are gonna be doing maybe your next project. You guys are gonna do more very core single link list. But I'll give you the basics so that when you guys see your project for tomorrow, you at least have some ideas on how to go about it. It's very easy, but everything about single link list is about whiteboarding. So why waiting for? She personally asked me about this thing yesterday, and she was the one who pushed it. And I don't know why she's just ping that Yoda or something. I don't want to start this thing. She will definitely tell me to recap. I don't want to go back. I mean, somebody tell me that kind of thing. If I say no, I don't know how the person feels. Can someone just drop a message for Yoda or something that we've started? Once again.
Okay, I'll that.
Yeah, please, because I'm going to start soon. So, yeah, back to my environment. Okay. Okay, that's it. So now let me just include, before I start explaining further, let me just include this. The guys I'm gonna need. Definitely I need some guys here. Standard library and standard IO. Those are the two things you need, very basic two things you need. The standard IO is because I likely want to print something.
There now.
And who's that person? The standard library is because I want to use the malloc. Okay. Bone, is that Bone now? I'm hearing his voice. Okay, nice. I've muted him. So, okay. This is dot, sorry. So, a single list is just very magical, like the way this guy explained it the last time. You can have a single linked list is null when there's nothing inside. Okay, just null. No. It's empty. Like nothing is there. This is what you find, empty. But the first time you add a list to it, is you're adding. If I want to add maybe something like, maybe I want to add my name. Okay, let's say I want to add Pascal. So Pascal will be here. So Pascal will be a node, right? So yeah, it will be a node. So it points to where the null, because at the first instance, Pascal was null. Okay, so first instance, Pascal is null. So have you started recording? Who's recording? I need someone to identify that I am recording. Who is recording? That bot is what I don't want. That bot. But what? No. I need someone that will record and won't have any issues with the record. Do you know how it drains when somebody makes a session here without the record and everything just goes down doing that? So please, somebody should record, I beg. Geraldine is not here. And that's why I say you'll be here, but she's not here now. You that always records. All right. Well, let's move on. So for the initial stage, let's say this is our list. It's always empty. It's null. So when I put when I want to put a node, let's say Pascal as a node, you get. So Pascal comes in as a node and points to where the null. Okay. So if I want to add maybe someone like Pius, okay, I want to add this guy. I also come in as a new node. So let's say empty list here. Okay, so there's empty list. Then here, add Pascal. Okay, just add Pascal to the list. It adds Pascal. Now add Pius, right? Already we know what the list was. So if you're adding Pius, it's going to add Pius here as well. And there's something about this adding of a node to a list. Sorry, already existing lists. Okay, so you see, so this is how it looks like. So Pascal pointing to null, Pius pointing to Pascal. Like that. If I keep adding, that's the way it keeps growing. Okay, the list keeps growing. Let's say add Victor, right? So let's see. So Victor comes in here. Very, very interesting and very simple. Single link is one of the simplest. The one that looks a bit harder is double. So Victor comes in, points to Pius. Pius, which is already pointing to Pascal in the list. And Pascal as the last one. So Pascal here is the tail. Victor is the head, okay? We always have one head here. That's the first node. The last is always the tail. And the weight points to null, okay? So yeah, that's it. So yeah, what else? Yeah, we always have it's good practice to always keep a reference to the head. So we always have a pointer. We always call it the head pointer. Many people always kind of why is the head? Why can't you call it why can't this head also be called the node? Okay, we can call this the first node, so we don't confuse it. Okay, Victor is the first node. Why? To store the head, just help us to keep track of the first node. That's very straightforward. So this head keeps track of Victor. So head keeps track. That's it. Keeps track of this. Okay, of the first node. So that's why somebody was asking the question last time. I wanted to answer the person. Don't always call the first node the head. Just call it the first node. The head is just where you keep the address of this first node. Okay, just keep it there. So at least we have reference to the head of that list. So the head of the list keeps track of the first node. Okay, that's like simple. So every time we are served this head, we can make reference to Victor. And from Victor, we can get Pius. From Pius, we can get Pascal, like that. So once we know the head, we can know the rest of the list. Okay? But there are some cases, if you don't write your program very well, you find out that, let's say we want to add another person here. Let's say we add Bona here. Let's say Bona is here, okay? So we add Bona now to this list. And then we have, okay, this is Victor's list. Let's put it back to Victor. Okay. This is Victor's list here. All right. So we add Bona to this list now. So now this is Bona here. Bona becomes this. So Bona will point to this, right? Sometimes if you're not careful in this single link list, you might break this list like this. Very, 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 very delicate. You have to be very careful when doing things like this. And this thing only happens when you are trying to either swap. They might say you should swap Victor and Pius. So that means they say swap means Victor will come here, Pius will come here. If you're not careful, once this link is broken, this list is destroyed in memory. You can't find it anymore. It's lost. So that's the thing. So there are some things you can perform in the list. From what I learned in ALX, you can search for a node. Yeah. You can add a node to any position you want to add. Currently I'm adding this node to the first. I'm adding it to the first, like I'm adding it to the head every time. If you look at from where he added Pascal, Pascal was added here, then Pius came in front, Victor came in front, Bona came in front. But you can actually add a node actually to the center here if you want to. Like if I want to add to this list now, let's say I want to add Susan, something like this, okay? Yeah, I can come and if I want to add Susan to, let's say, index 2 or index 3. Now, just like an array, a list also starts from 0 to count. So this is 0, 1, 2, 3. So we have, actually there are 4 nodes, but starting from index 0, they actually what? Pascal has the index 3, right? So if I want to add Susan to index 3, it's just be something like this. Bona, right? So let me just copy everything, sorry. So I'll just add it there straight up. It's very simple. So 0, 1, 2, 3. That means that Susan will come to this place here. And that's it. So she's been added now to index 3. Okay. All right. You can actually delete just the way you're adding as well. You can delete some of these guys. Okay, if I want to say, okay, delete the node at index 2. Okay. Yeah, that means you have to use a free, right? Yeah. So if you count it is 0, 1, 2, right? That means Pius has to leave this list. So all these things you see me doing here, they are operations that you can perform in the linked list. But yeah, these operations now are what are performed by writing the codes. You have to write codes that will do all these things. You know, if I now say, okay, no, swap first and second node, okay? See, so that means if I have this list now, I say swap it, swap first and second. So what's that going to be then? Who can tell me? Let me increase this guy. So who can tell me what if I say swap the first, second node? What's it going to be?
Susan will come
What?
to Victoria. Victor will come to where Susan is. Susan will come to where Victoria.
I'm sure you.
That's wrong.
Not that you're just
You said it's 0, 1, 2.
No. Swap first and second. This is first. This is second. This is third. This is fourth. Okay. So if I'm to swap this, that means this guy will come here. Who's that person? No. Is that Prince? Then
Sorry,
okay.
that's not
See?
me. Oh.
Swap first and second. Okay. So that means that Victor will come here, Bona will come here. This swap, delete, add. All these things you are seeing are operations you can perform on a single linked list. You can even find the length, find the length as well. So what they say, find the length, just the size, okay? How many nodes are there of the list? Find the length of the list, okay? That's the same thing. Same thing. So if I say find the length of this, who can tell me what's the length? Currently, we have this now in memory. So what's the length of this? What's the length?
Because the null byte is 5.
No, minus is not minus. You can't count up. This is not a node. How many? Find the length of the list.
It's 4.
Yeah, that's 4, right? Makes sense. You can even print as well. You can print the list. So all these operations are things that will be performed in code. Nice. Okay. Is your life? How do you can this for Africa? She's not here still. Anyways, it's fine. Okay, let's move on this. So now we can actually print the lists. You can print the list from the tail backwards. You get like you can print the list in reverse. You get so that means from doing that, that means that this will look in this form. In reverse will now be like this. It's this guy here. Oh no, don't worry. Print reverse will just be start from Pascal and print all these guys, right? So it's going to kind of print it like this in reverse. Normally, the printing should have started from the first node. If it was to print it normally, like if I was to print this thing normally, like print it in the normal way, okay? So it should just be Victor, Bona, Susan, Pascal. That's it. That's the normal printing. It starts from the first and goes down to the tail. But to print in reverse now has to start coming from the back. So it starts from the tail and moves down to Victor. That's the printing in reverse. Okay. So yeah. And yeah, one other beautiful thing again is very beautiful thing is for you to print in reverse, it's wiser to actually reverse the list first. So before you print this in reverse, it's very, very wise for you to reverse it. Very important. Because by the time you are in the tail, you can't go back, because you know that a single linked list is one-way traffic, like it's forward ever, backward never. Like once you are moving that forward, you are moving forward. You can't go back. But if it was a double linked list, then you can go back definitely. That one has 2 links. But this one is just one straight access, like you're moving in a road. If it's a one-way road, you can't turn your car backwards and move back. It's not possible. So that's why for you to print this list in reverse, first you have to what? Reverse this list. And the way they reverse it is very, very smart. This reversing, let me teach you how they do it. To reverse this list is just to reverse the link. As simple as that. Reversing it will just be set this Victor to point to where? To null. And change all these links face backward. All these links will face backward. I'm going to stop here and ask questions now. So I'll answer questions from here. And this guy no longer face here anymore. So it's going to be this. So by doing this, you have reversed the list. Look at this. Look at this one here. And look at this one here. You see the difference? Just reverse the link. That's all. So if Victor was pointing to Bona now will be pointing back to Victor. If Bona was pointing to Susan was pointing back to Bona. If Susan was pointing to Pascal will be pointing back to what? To Susan. Then the head now, that head I was telling you guys about. So the head now will have what? Pascal as the first node. So once I have Pascal, here actually the head is having what? The head is having what? Victor as the first node. Does that make sense? The first node here is Victor. But by the time I reverse this list, I want to talk about this because this is what you guys are going to put next, I guess. So let me just give you guys the idea. So the reverse is reverse the links, like change the position of these links. Let this, since it's facing backward, let it face forward like this, and set the head to the tail. Here, the head was the first one here. But once you do a reverse, that means the head now becomes what? The tail. So if I want to print now, like I did here, it's going to start printing from where? The head. So where is the head? The head is what? Pascal. So after Pascal, what's the next? Susan. After Susan, what's the next? Bona. Like that. So it's going to print it until it prints what? Victor. Same question, please. For more of my explanation so far, if you have any confusion, feel free to ask me now. Any questions? Any confusions? Anything that is missing that you feel is missing, or anything you feel you don't understand? Ask me now. Ask me now.
So, boss,
Is anyone
this is
there?
just how it's going to be.
Sorry.
This is just how it's going to be written.
Okay, now.
No semicolon.
I just gave an over. This is just a brief description. We've not entered code yet.
Like pseudo code. Oh.
Exactly, like a pseudo code. We've not even started the main thing.
What is this?
Single linked list is very deep. The codes are very, very. That's why I want to break it down first. If I don't break it down like this, I rush into code, you will not understand it. That's the truth. It's deep. What did you say?
We are inching closer to the moment of truth. Of Christ. Let's hear from
Please, can you be audible?
Don't ask questions that are not within this. Please, you're already going to code, saying this integer data type. I'm not even started writing code, so I've not entered codes. I'm still English. I'm still using English language to explain this. So I guess you guys understand the reverse how I reverse this to become this. I just have to switch the links and set the null to this. Let Victor now point to the null. You know, before Pascal was pointing to null. So Victor now is pointing to null. Oh, sorry. This guy, I didn't write it very well. Okay, so that's a head. All right, so yeah. So make the head then to be Pascal. Simple as that. Very, very simple. So those are the kind of things you can perform in the linked list that I remember. And there's one other one though. There's one other one. Let me show you guys something. Look at this. Look at this list.
Compass guys becoming 2.
Don't worry, I'll explain. So just like an added bonus for you guys. You can read about it later. What do you think about this? Are you aware that if I reverse this list, I might still get the same thing?
Why not?
Let's say this is this is a normal list. This is a normal list now, right? This is a normal link list, right? Okay. I'm not telling you that if I reverse this list, I might still get the same thing if I reverse this list. Even though I reverse it and the whole links change back. Like if I reverse it now and this Pascal here now points to null and change all these links back to reposition itself to face front. Everything starts facing front like this. And this one as well. And this one goes out. This is the normal link list, right? The head here was Pascal. The head here, the first node here was Pascal. Are you there? Then after reversing it, the head here became what? Pascal again. I was like, oh, what's happening here? The normal link list was this. And when I did this again, I still got this. What's happening? So when I want to print, if I want to print this now, it's going to print something like this. Maybe you don't know. It's going to print Pascal, Bona, Suzanne, right? Why again? Okay, and Pascal. Oh, wow. After I reverse it again, if I still want to print it, it should give me the same value. This is called a Palladium linked list. It's called some call it circular though. I don't know, but I understand it as a Palladium. It's a Palladium. A Palladium is
like circular linked list.
Exactly. It's like a word that when you call it forward, like something like how will I explain it to you? Like oh, come on then. Something like ends with like LOL. Yeah, like when you look at the letters from the front and look at it from the back,
You can use it for Q.
they are always the same. Like when you look at the letters from the front, like when you look at LOL and you call it at the back as well, LOL, they're still the same. So if you look, that's why I said this is normal link list that we were given before. But after you reversed it, you find that you still get the same thing. So it's called a palindrome. You can read about it. It's a palindrome linked list. A palindrome link is such that when you reverse the list, you still get back the same list. So if I go, Pascal is pointing to Boma, Boma is pointing to Susan is pointing to Bona, and Bona is pointing to Pascal. Now I've reversed it now. Now look at it now. Pascal is now pointing to Bona, and that's it. It still gave me the same result. Forward and backward, same result. Like after I change the links to face front, and it still gives me the same result when I print it. And when it was even facing back as well, like this, it still gave me the same result as well. So if I'm printing Pascal, Bona, Susan, Bona, Pascal, and here I'm printing Pascal, Bona, Susan, Bona, Pascal, I still get the same results. Okay? So that's just an added knowledge for you guys. You can read about it and yeah. So any questions so far? I want to go to a little bit of coding right now. Any questions? Any questions? I just summarize everything you're going to be seeing in ALX when it comes to the list. Like everything you can see. Everything. Okay. And just the way you are adding this list. I told you guys something, right? When I was adding Susan, adding Bona. When I added Victor, Victor came to the front. I added Bona, Bona came to the front of Victor. I added Suzanne to index 3. That means 0, 1, 2, then 3, right? So I have to add Suzanne in between Pascal and Pius. So 0, 1, 2, 3. So that means Pascal shifts. I want to put Suzanne inside there. That's what it means. Okay. So just the same way we're adding like this, don't forget that we can also add from the bottom as well. So we are adding at the front. If you look at when I was adding Pius, I added Pascal. This is Pascal. I added Pius. This is Pius. I added Victor. This is Victor. If I say, okay, from here, add Cynthia, right? Let me say add Cynthia now at the end of the list. All right. This will just come and say, okay, you want me to add Cynthia at the end of the list? Okay, thank you. I will just come here and add Cynthia where at the end of the list. So the Cynthia will now be here. Cynthia becomes the tail. You have a new tail, and the new tail is what? Cynthia. Do you see how beautiful linked list is? Very beautiful. It's so beautiful that when you understand it like this in reality, you can easily convert it to write to codes, but it's not easy. That's the case. Writing the codes are not really beans, anyways. It took me days and nights to really perfect it, though, to an extent. I won't tell you that I'm 100% perfect, but to an confident in it. So add Cynthia at the end of the list, add Cynthia at this section, okay? So when we added Bona, Bona came to the front of Victor. So but now we have Cynthia at the end. So we can add at the front, we can add at the end. Okay. All right. So there's a concept to that, but I won't talk about it yet. Yeah. As time goes on, you understand why ALX are teaching you guys all these things. The reason why they want you guys to know all these things is because you guys are going to be doing class structures very soon. And if you understand this linked list, bro, forget. The last structures will be very hard for you because there are lots of them. There's binary tree, there's hash table, there's sorting algorithms, there's which other one is there again?
Bubble
There's
sort.
such, and that's sort algorithms. Which other ones do we do? There are lots of them, anyways. Lots of them, lots and lots of them. You're gonna be doing. So yeah, if you understand now, you'll be very happy doing those projects. Because those projects I mentioned they're all group projects. They are not tax. They are group projects. Okay, guys. In the absence of no question, I will be starting to write the codes now. Okay. She's not yet here. Well, I guess I tried to an extent, and I see here. Yeah, please. That's the one that I have to start coming and saying past this recap. I want to recap. So guys, I want to start code, okay? I'm gonna clear these guys off and
So I think before you start,
guys
you
have
text her now.
So?
If you just drop message for her, make she come online. That's all.
No, I think it's not has dropped message.
Yes, I've dropped message for her.
Okay.
Yeah.
So all right, let's put. I guess there's a video so she can watch the video. Okay, so this is it. I want to add. What should I add to this list? So the first thing that comes to mind is let us create our structure, right? Structure. That's the first thing. Building your structure should come to mind. Some people always add integers to their struct, but I feel I should add names. I want to add names anyways. So that means I will call this type def struct. Okay. Students, I will call this students. I want to create a struct that will give me student list. Let me call it student list. Okay, so yeah, makes sense. So Same name I use here. That's what I do. I make my life very easy. It's the same name I use here as well. Okay, as a type dev is just like an alias. So this is the alias I'm using. But that's like making my name here to be the same thing my alias. So I don't have to stress myself. It will work that way as well. It's just a tip. So you guys can, yeah, give you guys a tip of how it works. Since I want to store names, okay, I'll just create what a pointer because it's gonna names is a string. So I will call this student name. I'll just call it names, okay? No need of too much grammar. Names. Declare that as names, and every name has to point to the other name, just like I explained. So we have to declare a link. We have to what? Also initialize a link here, like declare a link because we have to every structure we create is a node, and each node comprises of a name and a link. Like this, Pascal is a name, this is a link. All right, so yeah, so that means the name is this, so you have to create the link. So what is the link? You have to create the link. The link now will be a structure as well because it's actually pointing to a node. So definitely we have to create a link that looks like a node as well. So we have to use the set struct because where it's going to be pointing to, like something like next, okay? A link called next. So we're going to call the link the next. Yeah, and that's a pointer. So we close this guy as well. So yeah, so we have the name, which is Pascal, and the link. So this link we just hold the address of the next node. That's what you have here. This link next here holds the address of the next node. So you must declare it as the type, the same type, because where it's pointing to, you are holding the address of a struct student list. So that means that you must declare that next because this next will hold an address. You know, again, it's just like saying something like this int asterisk ptr. Again, is equal to something like that. Let's say an address of maybe a or something. Yeah. So that means if this is a, and definitely we want to get the address, that means a should be integer because this ptr, the pointer is an integer pointer. So that means I have to declare what a as what as an integer as well. Yeah. So that means if this next is pointing to, it's going to hold the address of a structure, it's a node that is of this type. That means I must declare this pointer as the type. Does that make sense?
No, Mr. Pascal, please take it over.
How can I take this over again? Okay, let's do it this way. Let me ask you a question. Number 13. What do you think number 13 does? This number. Do you understand number 13?
Yes.
No, I'm talking to the lady that asked that question. I know many of you understand that. Abang, do you understand number 13?
Not really.
Anyways, what's happening here is I'm passing the address of this variable A into this pointer. So this pointer will point to the address of variable A. So this thing can only work only if A itself is an integer. If A was a character like this, it can never work because character and integer are different. The two types are different.
Oh, okay.
So it must be an integer, okay? So that's the reason why I said that this next you are seeing is pointing to a node of this type. So I must also declare it as the same type as well. So that's what I'm explaining here.
Okay.
Okay.
Yes, I get
So
it now.
you must
Thank
have
you.
this next must have the same type because this next will definitely point to a node. So this next you are seeing must also be of type student list. Okay. So this is the first thing we build first. This is the complete structure of a node that will have the names of the students. Like this structure, what happens here is this structure here will represent a node, and that node will contain what? The name and what? The link to the next node. Okay, so yeah, it's just like saying I want to create a struct type def of a struct person, right? So a person has what? A person has a person has a name, a person has an age, right? Yeah, a person has what? Also has a name, has an age, yeah. Also has his address, right? Yes. Has an address where he lives. So this is just like a structure that will hold all this data. All right. So it's going to store this data. There are more. You can write more data. So every time we create a person, we are creating it with its members as well.
Okay.
You get, if you are creating a person now in memory, we are also creating it with its members. So every time we create different persons, we have each person will definitely have all this information. Like you get, they will have all this information. If I create Pascal now from this struct, if I create a person now called Pascal, the name will be Pascal, my age will be there, my address will be there. I can create another person as well from this same struct as well. So I'm not teaching struct today anyways, but I'm just, yeah, again, you guys have an idea of struct already. So structure just help you to create what? An object, kind of. Let me use an object in memory, and that object will have different what? Members. Like it has different member variables, okay? That is pertaining to that particular what? Structure or that object in memory. So this is a person. A person can have a name, an age, an address, and stuff. You get. So I can create like 10 persons from this now. 10 different persons from the struct. And when I create these 10 persons, in fact, let's make this thing very interesting now. Let me pass in these guys. Let me add this guy here. Since a student has a name, a student will have an age, right? And a student has what? An address. Or instead, let me just say software. Let's see stack or course. Let me say course. Okay. Yeah. So it's that software, it's data science or whatever. So this is this is a kind of student list. Okay. So these students will have a name. This student list, I'm going to create different students from this structure. So every student will have a name, an age, a course, right? And a pointer to the next student. So every student will point to each other. It's just like saying, if I have Pascal here created as a struct, as a node, Pascal will have what? His age. Pascal will have his course as well, and a pointer, right? He's going to have a pointer to the next student. So let me just do it this way. Let's say the next student now is I created now is Ahiwe, right? So Ahiwe, he will now be here in the memory. Ahiwe we have his own age as well. And Ahiwe we have his own course as well. Right? So all these guys we have their next to this. They will have their next to the next pointer. All right. Oh, yeah, I've gotten one student. So I've gotten one student. So this is pointing to this guy, and this guy as well will point to another guy as well. So next to another guy as well. So different students in memory, but each of them pointing to each other. Maybe another student to come up here again. Maybe Pius now. Pius too will have his own age. Right? So that's how they point to themselves. So I'm just creating a list of students that each of the students have their own bio data. That's the beauty about it. It's like an array, but this one is more dynamic than an array, because I can remove a student. If a student leaves my school, I can remove the student. I can even add a new student back. I can delete the student. I can change the student name if I want to. I just need to get a student ID. That's the index. Give me your index, okay? I'll just go and search for the students and change this information straight up. Very, very fast. So that's programming for you. You see, I'm started thinking logically now how these things work. So you can just create a list of students just by using this particular structure. this structure now will give me the power to be able to do that. Any questions so far before I move further? Any questions so far, please? Okay. When people are quiet like that, I feel that you are getting me. But he will always say, I want people are quiet like that, they're not getting nothing. Are you so funny? He says, when people are quiet, they're not getting anything, nothing is entering. But actually, that's how it is, though. This structure will just help me to build that list. It's just like it's just like a prototype. This is just like a prototype. I'll be using this prototype to generate different students of different names, you understand, based on this prototype that's here. So yeah, that's what it is. So use this prototype, Pascal, create many students as you want, but each of them must have this information. All right, and this one will just be a pointer to the next student. Okay, I want to create 3 students, three of them. I want to create 3 students, and I'm going to do it in a static way, though dynamic way though, but I'm going to spell them out so you can see how they're represented in memory. I don't want to rush into deep coding. If I rush into deep coding, everybody here will be lost. Linked list is deep. It's deep than the way they are even teaching it in the online that you guys are watching. Okay, first things first. Let's do this. Let's create Suzanne. Right, come on, every time. Let's create John. Okay. Let's create our first student. Our new student. Yeah, John is a new student. He comes into, he's the guy that is coming in, starting school. He comes into my school, my new school. So we're going to create John, our new student, right? So yeah, our new student. So John is our new student. So let's create him quickly. So to create John, it's not hard. First, I have to declare John as a type. Okay, like not John, sorry. I have to declare a new student as a type of this my structure. So what I will do is to create that new student, I will use this my structure type, which is this one here. This is student list. So I will create him from this declaration. I will declare a new student using this my struct type. So student list, new students. That's it. So but this is a pointer, please. Don't make that mistake. It's a pointer. Very important because we're going to do it dynamically. So we need a pointer since we're going dynamic. All right, we can initialize it to null. First things first. Initialize it to null. So it's null first. Nothing. All right. So yeah. So now we have declared this pointer as a type of this, but nothing exists in memory yet. Nothing exists in memory until we create what? Use malloc to build this prototype. Malloc will help us to create that object. That's why sometimes you see malloc is very powerful. It's not just do malloc of 10 bytes and 16 bits. No, the malloc of 10 or malloc of a size of something. No, malloc can also be a size of a structure. And when you use malloc on that structure, malloc will go and create that structure the way you have represented it here. I will test this thing in memory. You see how it's going to be. So now I've done this. I've declared this new student as a type of this struct. I will now pass malloc into that new student pointer because malloc returns a pointer. Everybody knows that. Malloc will return a pointer. So I will do a malloc. Guys, just pay attention, please. So to the size of this guy here, this student list, sorry, this student list. So guys, please watch what happens at this point. I'm going to run the program now. From this line 16, just watch what will happen in memory. By the time this malloc creates this size of students, it will build the node, the first node. It's going to create the first node in the first list. Okay? So I just like to have a head in everything I do. So let me just call this since I've started the execution, let me enter the main because it starts from here. Execution starts from here. So please, it's important to start from your main function, okay? Put everything inside your main function. So now I need to have a head because, yeah, I need to have a head. So I need to set up a head a head pointer that will keep reference to the first student that was created. So I want to create my first student, who is John. So yeah, I'm going to create a head pointer that will store that, keep reference to that. So I'll just make him null for now. It's empty for now, okay? Yeah, I'm still going to explain this head soon. You will see the power of head. Okay, now let's test it. Let's test it. Ta-da-da-da. Program is running. But so okay, yeah. So good. So next, here we go. So now execution starts from the main, which we all know. So now if you look at it, the main function has two pointer to a student list. See, 2 pointers are there, which is the head and the new student, right? So let's go next. Let's see. I want to just show us something about malloc. Malloc is very powerful. So 2 of them are null anyways, so they are null, so it's nothing. So by the time this one gets executed, you will see what's going to happen at that point. So when I say next, you see, it has created what? The node. It has created this object. This is a complete node in memory. And the node has what? A name. It has what? An age. It has what? A course. And it has what? The next pointer. This has built, you see what the malloc has done? It has gone and create this structure for me. One structure. This is just like a copy. Make a copy from what I have. You have a prototype. You're telling malloc, okay, pass that copy to malloc. Malloc will go and from that thing. It's just like, how will I explain it? Just like you want to build robots. Okay, so you have a prototype for your robots. So you just pass that prototype into that malloc, and malloc will go and create. It is an image of that prototype. It will create it in memory. That what it will just go and, just like an image of yourself. You want to have yourself. You want to create yourself. You now pass yourself to malloc. Malloc now creates something that represents you in memory. So that's what he did here. He went to memory and created.
I'll go to Pascal.
Yeah, ask a question. I think nobody's asking me a question. Who is that? Who called my name? Okay.
No, he was saying what happened to Pascal. Let's continue.
Okay. Anyway, can you drop the link for the new Slack? I guess you guys are aware that you'll be moving to Discord from tomorrow. Okay. So people are very good in typing. They know every theory. They're very good. Okay. I like what that guy posted there, though. Yeah. So that is it. This is my prototype, and I just had to build from the prototype using malloc. Malloc just help me. Okay, you said I should do a malloc of this for you. Okay, don't worry. I'll go and create what you told me, what you passed into me, a prototype of it. I'll go and create an object in memory or something in memory that looks like what the prototype you have served. So this is your prototype. You served it into malloc. Malloc now came and represented the prototype in form of an object in memory. So this is an object in memory. Okay. So now let's fill up that object in memory. That is actually one student. I want to create one student. The first student in memory. Okay. Now this is it. I'm taking it slowly. Why these things are very advanced, but I'm just taking it like a baby kind of stuff so you guys can understand it very well. So this my new student has what? Don't forget, it's a pointer. So we have to what the reference is. You can use this method or you can use this method anyhow. It will still work. Okay, it will still work. So you can do dot age is equal to, since it's just a secondary school, so means 12 years old. Okay, so yeah, this will now be his name.
Pascal,
His name is what? John. Okay, then what else? His course, right? He has the course software engineering, right? So now let's do that quickly. So let's do a dupe, str dupe. Let's duplicate a string into it, right? So let's duplicate software engineering. Okay, yeah, software engineering. Very interesting, right? Yeah. I'm coming. I'm going to answer your question, please. Let me just pass this information. Then, since I have no student, just one student, that means you can't point to anything than point to what? To null. Since there's nobody there. So, yeah.
Yeah, I'm not
Nobody's
changed the
there.
course.
So, yeah, I know. Thanks. So now let's now take this new students point to nothing because the list is empty, right? Hey, come on, man. Point it to nothing because it's empty, right? Yes. And don't forget that since this guy is our new student, our first student, then I will make him the head of the class. Okay. So I'll just set him as the head. So you are the first. Okay, no problem. Since you're the first, then give me your location. So let me just keep you like serve him as the head, like store the address in the head. So at least we know we have the first student in memory. As simple as that. So his name is John, right? So let's just duplicate this to make it more effective. So John. STR dupe. So we have then we give, since he's the first student, he becomes the head of the class, right? He's the first, so he's the head. We store the address in the head, right? So we store that guy there. Okay, so let's do a test and see how this guy will be created in memory. Let's go. So let's go. Null, malloc. Good. So malloc will come now. STR dupe. We go and store the name inside. Let's put the, I think it's a pointer or something. Let's see. Duplicate, yeah. So they have a name. We have his age. We have his what? Software engineering course. And we have what? The next to point to nothing. So it's null. So it has null there. And we pass the address because the head has to point to it. So yeah, the head. So the head is no, the head actually identifies him as the what? As the first student. So John is our first student. John is our first. So this is the first node that is created in memory. Okay. He has a name, and the name is what? Pascal. Sorry, his name is John. Then he has an age, which is 12. And his course is software engineering. And his next pointer points to nothing because you understand there's nothing there. He's the only one that was created. So we only have only John inside. So the head, Mr. Head here says, okay, I have a head. So I have one person as the top of the class or as the first person that was created in the class. So he becomes the head. Any questions so far? So
Yes.
the guy that wanted to ask me a question, ask me a question.
Okay, yes, I want to really ask a very, very simple question. I've
How
noticed
do you know
that
it's
you're
simple?
using type dev.
How do you know
Hello?
it's simple? If you don't know the answer to the question, okay, go ahead, ask the question. Ask the question.
Okay, I actually want
Anyways,
to use.
I get. Mm-hmm.
Can I talk? Are you guys hearing me at all?
Somebody's line is breaking. I don't know if it's my line or the line.
Yeah, we can hear you. I think
Yeah,
it's
we can
always.
hear you.
Shoot. Fire down, please. What's the question?
Okay. Why do you use type dev to precede your structure?
Yeah, because of the alias. I don't want to start every time I write student list, I will come and put struct in front. So this is a short form. It helps me to
Because I
precede this.
actually learned it in a very different way. I don't just precede my structures with type dev, so I'm very surprised to see type dev there actually.
There are different
Can
ways to do it. There are
you just
different
break
ways
it
to do
down?
it.
Can you just break that type dev down? Can you just break that type dev down? Why do you just put that type dev there?
Who is asking that question? Who is asking, sorry? Okay, Henry.
Mr.
Okay, you're the one, right?
Yes.
Mr. Pascal,
Yes, yes.
I think I
Okay.
have a simple answer to his question, and then I'll ask my own.
Okay, answer him. Thank you.
Okay. If you discover we did struct and type def almost at the same time. So the simple difference between struct and type def is that if you precede your distance, if you precede the naming of your structure with type def, then it gives you that power to give it an alias. Like that type def you used in the number 4 gives you the strength or the power to use that sorry.
Sorry, guys. Go ahead, please. Sorry.
So when
ahead.
you use that type def to precede your
Mhm.
struct in number 4, it gives you the power to then give another name to your struct, as you can see
Exactly.
that the
I can put
alias
Pascal
was
here if I
given a
like.
number 10.
Yeah.
But then if you
I can
didn't
put
use
I can put Henry here as well.
yeah.
Yeah, go
But then
ahead.
if you don't use that type def to precede it, then you will not have that power to give it an alias. And then anytime you want to use that, you want to use the struct, as you can see maybe in that number 15, where you wrote a student list, you would be forced to use struct before you type that student list.
And that's very
So
correct.
it just gives
Absolutely
you
correct.
the flexibility. So my
I think
question
no, wait, Henry actually knows it. He just wanted to say it's a simple question. So I guess he knows it anyways. Okay, go ahead, ask your question. Yeah.
is calm down a bit.
Okay.
Like in this line number 20 and line number 22, why did you use that string duplicate or string dog?
Yeah, it's because I don't want to,
Let me
that
just answer that question.
okay.
Go, pressure.
You'd like guys to answer.
Okay, actually, it is an array. From let me just see the upper part of the code. Okay, now that student's name now we use characters and it's actually a pointer for the student. So we cannot just use normal text or string of characters. You have to use the module that helps us to like copy the code. Use string duplicate text, also use string copy to actually copy the text or the string literals and add it to your name pointer. Some people actually use arrays for this particular task too. But since you use pointer, you cannot just put string of text there. So you have to put it into a string copy function or string duplicate function.
Okay,
Is that clear?
thank you. Yeah.
I like the fact that some of you answered your questions yourselves. Makes sense.
No, it's not clear, please.
Okay, oh, who's that? Somebody asked the question is clear. Okay.
Yes.
What is not clear, please?
It's
So what's
not
not clear,
clear,
please?
Okay.
Okay, what's
Maybe I
Just
can.
the add up, yes.
I think the guy did not explain it well, but me, I understood it. You get? I understood it.
Okay.
And
Thank
that's
you,
why.
Ghana. I'm listening.
Okay. Okay. He said that the reason you are using that string duplicate, that is string up, is because it is a pointer. You know, when you have a pointer, it means you are pointing to a location. So what it wants you to do is to go and that string up now gives you the power to go to that distance. Maybe I should wait so that Pascal will come. Again, so I'll continue.
Okay, no problem.
I had a call. Sorry about that. I had a call. Can you guys hear me?
Yes, we can.
So,
So
yeah, actually, the thing is, yeah, somebody wants to answer the question. Somebody asked the question I didn't understand. Can you just throw more light so the person can be clear? Let's make this
okay.
interactive. I can answer these questions, but I want you guys give you guys a chance. So go ahead,
Okay,
please.
so I was trying to say that if you see in that place where he defined the struct def from that number 4, if you come to number 8, you see that it is a pointer that is used. If you come to that number 6 as well, you see that it's a pointer that is used. So it means that there is something in that location that is pointing to, that you cannot just enter it anyhow. You get it means it's pointing to the value in that location. So that string duplicate is like telling it to go and copy that value. Just like the guy said that you can use string copy to do. You say go and copy the value there, and that is what you see also in that char course. It's telling it go and copy the value, as in the one as in the value talking about the course the person is
Okay.
offering, or
Can I
the
add to
name.
that? Let me add to that, please.
Okay.
Now, string duplicate is, so you guys can be clear, okay? This is malloc plus str copy. It's doing two things. String duplicates, please remember everyone, this, I'm just giving you guys a tip. String duplicates is equal to malloc plus str copy. What I mean malloc is, string duplicates will go and count how many of these numbers are, which is John plus what, null bytes. It will pass it to the malloc. The malloc will go and create this empty array. Then string copy now will now copy this data into what, this array. So it is string, it is malloc plus str copy. Does that make sense?
Yeah.
Yes, yes, yeah.
You can go and read about string duplicates, okay? Like, yeah, so we don't waste time on that. So any question to this guy? Let's say Pascal. John is the head, is our guy here. So John is the first student and is offering a software engineering course in my school. Okay, so that's what John is offering. We can even make it look more interesting. We can, oh, no need to put school. Don't worry. Let's leave it that way, though. Let's leave it like this. Let's leave it that way. So yeah, so we have our first student. Let's go and create another student. Let's create another student. Let's see how it is. So now, this is the first student being created. Now I want to create the next. I don't need to stress myself, right? I'll just come here and copy all these guys and create the next student. Okay, so I'll copy this. Well. Can I truncate it? I don't know. Let's see. I hope it doesn't truncate it though. If I do a second malloc using the same variable, I've not tried that before. So the second student now, we want to create Pascal. Okay, that's me. I'm the second person to get into the school. So yeah, let me call this capital J. Capital J. Capital M. P, sorry. So his Pascal's age is 19. He's the boss. Pascal is offering data science. Yeah, he's offering data science there. Okay, so yeah. So for us to be more explicit, let's just have a second student here, okay? That's a new student. Let's just call this new student 2. So we're explicit. We don't want to make any mistakes. So let's call this new student 2. So let's make here student 2, right? I'm taking it slowly. I don't write programs like this, but for your sake, you have to just bring it to this level so at least you can understand it better. So this is new student 2. I want to create a second student. So now, yeah, this is where now I have the head. I already have one head. I can only have one head. Only one head. I cannot have head here and head, So this is the first student here. And the head pointer knows the first student. He knows it. He knows, okay, John is the first student. I know. He's the first student in the list. So he knows, right? So the second student is Pascal now. So now, this John here, this is next will no longer be null. It was not here. Yes, accepted. I can leave it. But now we are adding another student, so John cannot point to null anymore. John now John will point to null. What am I saying? So Pascal here will become the head because we're adding a new node, a new student. So Pascal here will now become the head. So this guy, sorry, you're no longer the first student. You're no longer the new student who entered. We have a new student now who has come into the school, and that student now is the second student. What am I doing? Sorry, I want to copy this guy here. Initially we had John to be the new student. So that's why we made him the head. But now we've added a new student, Pascal. So this John can no longer be the head again. It can't be it's no longer the first student, the first new student. We now have a new student, Pascal. So we have to go and set that head to Pascal. So that will be new student equals to new student 2. Okay. Yeah. So this new student now will now point to who? To new student 2, right? Exactly. So that's it. That's the function of the next pointer. So new student 2 will point to the new student. I'll explain this, okay? I'll explain this. Now, as I was explaining, when I was explaining this thing, I said initially a list is always null by default, empty, okay? When you add a student, let's say I added Pascal. Pascal will now be added to this list. Pascal will point to what? To null. If I want to add another student, say maybe Henry, right? So if I want to add Henry will become the new guy there, right? So Henry comes to the front of Pascal. So Henry will be like this. So Henry will now point to Pascal. Then Pascal will now point to where? To null, right? So that's exactly what I did here. So every time you add a new student, it becomes the first student in the list. Okay. So initially when I added John was the first student in the list. But I can't make John the first student anymore because I'm adding a new student now, which is Pascal. So Pascal now becomes what? The first student in the list. And that's why I said let the new student be equal, let the head be the new student, because the new student 2 is the first student now in the list. So that new student 2 now will point to where? To the previous student. That is the old one. In fact, to make it more interesting, let's call this the old student, okay? So that it shouldn't look more confusing to you guys. Let's call this old student now. Let's rename all these guys to old student. Old, right? Old. Yeah, old. He's the old student now in the list. So old. Let's call him old because he's no longer new. He's now the old guy. So old student, old student, right? Yeah, old student. So yeah, old. He's the old student, right? So now we have a new student. Let's just remove this 2 so to make it to look more interesting. So let's change this guy. Okay, let's take away the 2. Take away the 2. And take away the 2 here as well. Right, so yes. So that's the explanation to this thing, okay? So we have the old student, which was John. Now we have a new student, which is Pascal. And the new student now becomes the first student. That's why I have to set it to the head. So I have to update this student to the head because it's the first student. So don't forget, who is that person? This number 17 and 18 is important. You must declare what the pointers, because those pointers are what you will use to create those structures, the objects. So John objects will be the old students. This pointer will be the one that will hold all the information for John. And this new student will be the pointer that will hold all the information for Pascal. Okay, so now let's test it. Let's run it and see how it behaves in memory. Okay, no, this is old. This is new student pointing to old students. Nobody even told me that. The new student will always point back to the old student. That's the way it is. That's how it is. Okay, so now let's wait. If there'll be errors there, we'll debug it to change it. Okay, this old student equals to this. Oh, It says student, so that's my mistake here. It's supposed to be S. All right, let's test it again. This is very basic, very basic to what ALX is giving you guys. It's basic. What I mean basic is too simple. So I just want to make it simple so at least we get a real understanding of how this linked lists, how they work in memory. Okay, like how they are linked and the concepts behind them, using them. Okay, so it creates the first, that's the old student. So it's old because actually, yeah, definitely in a program that runs, you can't say it's John is the new student. Yeah, for now it might be the new student, but it's no longer new once it's created. And this once the new student comes in, John cannot be new anymore. So this is it. John is 12 years old. That's his name, John, and his course is software engineering, right? Yeah. So actually, he's pointing to null at that point. Yes, because he is the first student to be created in the list. So now we said, okay, we want to add another student, please. We need a new student this time around. So we're going to do another malloc again for a second student. So we do a malloc. So it creates the malloc for the second student. So we have the old student. If you look at it, old. This pointer has the representation of everything here. This is the old student and it's the biodata. So the new student now comes in. This is the new student, right? Yeah, of course. So we're going to put all this information as well as a new student. So it goes in, so he creates Pascal as a new student, Pascal, and his course, which is data science, his age is 19. So you see, same representation, same copy, okay, same structure, like the way the other student was in memory as well. So now he has done Pascal, he has done his course of study, his course is data science. So now for us to link it, we want to link it now. So that means that the new student has to point toward the old student. So if you look at it, this next you are seeing here, this next that is showing question mark here, will point to where? To this man here, to this John here. So now let's see. If I do next, you see that, come on, what's this? If I do next here, you see that the pointer, you see that this next here now is pointing to where? To the old student, which is what? This John here. You get? You see? So this is the old student, see him, and this is the new student down here. So the next now, his next means you are pointing to where? He's pointing to the old student, pointing backwards to the old student. That's the idea. Okay? So if you look at it now, this head pointer now will become, this head pointer now, we point, this head pointer you're seeing here will become what? This new student, which is Pascal. So it's going to point to where? To Pascal, you see? So this head pointer now is pointing to what? To Pascal, because Pascal is the first new student in the list. So with Pascal now, I can reference what? John. If I know Pascal, it's easy for me to what? To go to the next student, which is what? John. Because there's a next pointer there that's pointing to the next student in the list. So the next student in the list is what? Is what? John. This John here. That's the next student. So he's pointing backwards. Why John himself, which is the old student, is pointing where? To null. Nothing. Points to nothing. That's how it is. I already explained it when I started this session. The first person to get the list will always point to null. That's how it is. That's how single linked list works. The first person that gets there, his next pointer points to null. Then if you add another item to the list, that one you are adding will point to the one that was there previously. So that's why you see that this Pascal, when I added this new one, his next pointer started pointing to where? To the old student, which is what? This John here. Okay? So if I add another one again, that's how it keeps pointing. If I add another student again, that student will point to where? To Pascal. And why Pascal is pointing to where? To John. If I add another one again, that's how they keep pointing to each other like that, back to back, back to back, as easy as ABC. Any questions so far, please? Is there any question? Am I muted or am I invisible? Oh, people are here. Okay, so people are getting my concept. I'm seeing some 100%. Okay, I see. Cool. Any question, please ask. So, okay, let me ask a question. Okay, fine. I just taught you different types. You can do this, or you can do this. It's your choice. Anyone you want to use. Okay, you can use the one in line 28. You can use the one in line 29. I can decide to change everything to look like this. It's still going to work. It's still the same thing. Okay. So, and either ways you go, it's still the same thing. So, guys, as we all know that we're going to be leaving Slack very soon. I don't know how you guys are going to connect to me, how I'm going to connect to you. So there's actually a Slack channel that we created. You can join there. Ahiwe, meet Ahiwe. Ahiwe is going to add you to that station, to that channel. So you guys can be there in case we get moved from Slack, maybe tomorrow or next. I don't know when. Okay, so in the absence of no question, I have a question for you guys. Why do you think we need to set this head pointer to point to the first student in the list? What's the reason for doing that? Who can tell me that? Why? Why do I have to set this head pointer to the new student? Why is that?
Uh, okay, sir. Should I take that, sir?
No, it's you. Go ahead. I trust you. You're the
Okay,
boss. Shoot
I'm
your
not, sir.
shot.
I think why we
All
have to
right, go
set
ahead.
it back to the new one is because once by the time we want to start traversing, we should start traversing from the newest to the last. Like we are creating an effect of something that looks like a stack, where what comes last is what we assess first when we want to pick them out. So we just want the head pointer to point to the last distance so that when we start traversing, we start from the last one that came.
That's 101% correct. You even added some extra things which you're not supposed to add. That shows that you understand it very well. So that's 101% correct. That's beautiful. So that was the very correct question, answer, sorry, to that question. So that when we want to transverse, by the time we know the first node, or let me say the first item in the list, we can be able to what? Go in next to know the other ones that are behind, which is John and any other ones that are there. I just did only 2 students now. In a real life scenario, you might have up to 1,000 students or 1,500 students. So when I know the first student who came into my school, I can easily transverse and know all the students that are in my class or in my school. And the beauty about this kind of things is you can even search for a student. You can search for a student. I can decide to say, okay, let me add one more student and I can search for a student. I can search and say, okay, I want to get Pascal. Let me look for Pascal. I don't know. I've forgotten Pascal's address. I don't know which course he's studying. I don't know what, just kind of thoughts will come to your mind. Let me even look for Pascal. Like all the Pascals I have in this school, I want to pull them out from the memory. Let me know what are the about data. I can print everything out. So let's add one more student, then do some very, very interesting test case. So guys, any other question to this? You see the next guy, next pointer, pointing to the old student, and the old student himself is pointing to null, nothing. Okay, that null shows the end of the list too. You must have, if you don't put this null there, oh my God, when you transverse, you will just transfer to infinity. So this null must be dead. Your null must be set always to the tail. The last node must always point to null. Always remember that, please. It's very important. Okay. I'm giving you the concepts of linked list, single linked list to be precise. So, guys, any other question? All right. Let's add one more student. So somebody should write a code that adds one more student to this thing I've written here. Write the code, and I want the student's name to be Michael. Write that code, drop it in the thread. I want to just copy it and paste it here and run it. Simple as ABC. I want to add one more student. It's a challenge. Somebody should just write the code, complete code now. His name should be Michael. His name should be Michael. And his age should be 70 years old. He's the oldest, actually, one of the most matured man in my school. He's a new student, so his course should be let's call this AI, okay? Because of he's an old man, so he's very intelligent. So AI, right? So that's his course. Okay, so yeah. So this is our newest student. So with this data I've given you, please write the code just the way I've written them. Drop it to the thread. Thank you. And let's signify it, please.
Okay.
Sorry, Mr. Pascal, what's going on? I've not been here. But don't worry, continue.
Okay, I went to charge my laptop. Sorry about that. So what's been going on here? I have something like that. Well, structure has been going on here. Structures. Please, guys, write a complete code now. You are breaking it pieces to pieces. Ah, wow. One full complete code, like write it and send it, not breaking it like this. I don't know how to use it. So we're doing linked lists, but I want to also teach you the easier ways to write it, so that when we go into the real ones, the ALX type of linked list, you have more issues with. Okay, so this is it. So first of all, we created an old student, then we created a new student. We did a list like this, a structure, a student list structure. The student must have a name, an age, you have a course, and a link that points to the next student, which is the next. Okay. Yeah. So we have a head. This head, like Michael said, we need the head so that we know the first student in the list. This guy keeps track of that. So yeah, the old student is here, the new student is here. So the old student is John. John is 12 years. His course is software engineering, and he's pointing to null, which is because it's the first person in the list. So we added another student again called Pascal. Pascal is 19 years, right? So he's offering data science. So we need to connect this new student with the old student. So we have to what? The new student point back to the old student. So there's a link there, a connection, all right? So then, since Pascal is the first student in the list, which is the newest student, the head must keep track of the newest student, okay? So I gave an assignment. I said they should go and create a student using the same logic I've done here. Create a student named Michael, and his age is 70, and is offering a course AI. So they should go and build this. Give me the code, drop it in the thread so I can use it. So for the sake of those that are not here, let me run this program again so you can see how it works. Okay. Thanks. So guys, please stick around, okay? Like, so you don't ask back what I'm doing and what I'm not doing, what we're doing, okay? Please stick around, okay? Very important. If you miss just 10 minutes or 10 seconds in this my stuff, you miss a lot, trust me. So we go next. So now I'm trying to run the program. So this is just a declaration of the old and the new students. You must declare it with the structure type, okay? The type is student list. Because I'm building a student list, right? Yes. So that's null. Null. Some of them are null. It's null. Okay, so the old student, we're gonna malloc it. It's gonna create the what the object. So now we're trying to build the first student, which is John. So John, we have a name, we have an age, we have a course, we have what the next pointer to the next student, right? Yeah, so duplicate now, we're going to create what this John name and store it where here in this pointer, right? Yeah, because we have a character name pointer here. So that's the name pointer. So it's going to create it and store it there. So if we go next, so we have John here. So this is John's name. His name is John. So we have his age. His age is what? 12. So it's going to store his age. His age is 12 years. Then we have his course. His course is software engineering. So we have his course, his pointer, the pointer pointing to the array, string of arrays, character array, and his name also pointing to John because that's his name, right? So since John is the first guy in the list, it's going to point to null always. The first person in the list points to null. Or let me say, the first person to get into the empty list always point to null. I explained that in the beginning of this session. So now we are done with the old student. His information is complete. He has a name. He has an age. He has a course, which is this. And his next pointer is pointing to null because it's the first in the list. So when we want to create a new student, we are creating a second student again. The new one now, this is another one here. So we want to create Pascal now, right? So we create Pascal. Pascal is here, right? Yeah. So we create his course, data science. We do a duplicate, a duplicate. We create it for us. So he's 19 years, right? He's 19 years. So yeah, his age, the new student is 19 years. And his course of study is data science. Okay. Yeah. So now we have to connect it. So we have to connect this student with this student here up. So this next here will point to the old student that was here. So that's this one that is happening here. This new student will point to the old student. So that's it. So it has pointed it. So you see the next here is pointing to the old student, which is this guy. So that's it. So I'll now give them an assignment. So let's see if anybody has done it. So that was we just created two students. This is the first student, and this is the second student. Okay. So the second one, which is the newest student, is pointing where? Look at it. The next is pointing to the where? To the old one. As John. John is the old student, anyways. The new one I just created is what? Pascal. Okay, so yeah. I want to create another one now called Michael.
Okay.
Michael, is the code there? Let's see. Somebody created it. Okay, yeah, I like this. Let me use Onyeka Zone. Onyeka has created it. Wow. So many people have posted. Okay, let me use Onyeka Zone. Okay, Onyeka, nice. Okay. No, I'm going to make some adjustment. It's actually wrong though. Like, though the logic is correct from what I see. So Onyeka created this one. Let's see. So now, I think this is the old, this is the new. We can call this the new students one, okay? Like you said, let me just declare it. So we need to declare this thing Onyeka wrote here, right? Let's declare it as student list, right? Because we must declare it as a pointer. Student list pointer this. So let's call this a small letter new. Student one is equal to what? Null. Makes sense. I've not even started doing ALX single linked list. So this is still the basic ones. So now this new student now, let's change it. Yeah, Onika did this. He did a malloc. So to build the structure in memory. And that's correct. That's the first thing. Then he duplicated Michael's name, although he didn't put it in a string. He was rushing, I guess so. So duplicate this Michael's name as the name of the word of this pointer. As the name pointer. So name pointer will point to that location where Michael is stored, right? So yeah. So the next is 70 years old. Yeah, Michael is 70 years old. That's correct. And course of study is AI. So you do a duplicate of this AI string, and that's correct. That's very correct as well. So let's move on. So yeah, this is small letter N, it's visual. So yeah, so we have another one here as his, yeah. So this is where I feel he made some mistakes. So yeah, this new student here, we point to where? To this one, right?
Hello, Mr.
Yeah.
Pastor.
Yeah.
Hello,
Go
Mr.
ahead.
Pastor. Yes, that's not my code, though. That's not my code. I think that is not my code.
Okay, sorry.
That's not my code.
I thought it's your own. Mr. Olawale. I mean, you try anyways. But there's a mistake in the code. Lots of mistakes are there, though. So this new student one will point to the new student. That's correct. Then the new student itself too will point back to the old student, which I've already done here. Okay, since it's done here, no need. Thank you. So yeah, Wale, you tried. That's a good one. I like that. Nice one. You tried. I can give you 90%. So yeah, correct. So you see that this new one is pointing to this. This one here is pointing to old, and old is pointing to what? To null. See the connection, right? That connection is very important. This is the newest student here. Michael is the newest student. Michael will point to the new student that was there before, which is what Pascal. Then Pascal will point to the old student, which is what John. And John will now point to where? To null. You see the connection? Very, very important. So beautiful. I like that, Wally.
Mr.
And there's a new
Pascal,
person that know.
I have a question. This, if you, sorry, can you go up a bit?
What's the question?
I just want to show you, like, can you go up a bit? I'll show you the number, and then I'll use it to ask you the question. Because I want to see what is there, so I will refer to it. This 17, 18, 19. My question is it a must to initialize it? Or you initialize all of them here before you start writing this thing?
Yeah, because I'm still teaching the basic style of doing it. When we go into the advanced side, you see that it's different. This should be taught fast, Wale. Should be taught as well. Okay, so it's just a difference. One more, let me even remove it. Let's make it uniform. Everything will look the same, so it shouldn't be confusing you guys. It's still gonna work like this as well. So even though you put it like this, it's gonna work. All the same, okay? So ask a question here. Okay, we are good. So we have old students, new student, and a new one. This will be John, this will be Pascal, and this will be what? Michael at the end. So that's the 3 declarations that we need. So null. Okay. So now we are creating the first one. This is what the oldest student. This is John, right? John. So we create John now. John is 12 years old. John is offering software engineering as well. And John is pointing to where? To null. Okay. Yes. So we are going for the next student, which is what? The new student. We're going to create this guy now, Pascal. So we're going to create the next node. So this one now is pointing to where? This one here, which is the old is pointing to John's information. The new one here is pointing toward Pascal. Let's fill it up. So Pascal, 15 years old, okay, 19, sorry. So this is Pascal now, right? Yes. So he's offering data science. So he creates data science for his course as data science. Then this one now, this particular structure will point to where? To this one at the back. All right, because they must link, the link must link to the other one, to the node that comes before it. Okay, so before it, we have this guy. So it has pointed to this man. So the next node is pointing to where? It's pointing backwards. So that's what this guy did here. So this new node point to the old one, right? Yes. So set this head to the what? The head now will be this, because this is the newest guy here, right? So this head points, this is our head here. We point what to this guy. It's the newest guy we registered into the school, the newest student. So we have 2 students now. So we want to create a 3rd student, right? So let's create the 3rd one now. So the next one is what? Michael, right? So let's do Michael. So Michael, create Michael. So this is Michael. Michael, I want to create Michael now, see? So we have this old one is pointing here. This new one here is pointing to the 2nd box here. And this newest guy here will point to this last box here. So that's the whole idea. So let's go next. So to create his name, which is Michael. Then if we go next again, to create what? His age. So Michael's age is 70 years. Look at the code, 70 years old here. So it's going to duplicate his AI as well. So the course of study, Michael is studying AI. So yeah, so that was fast anyway. So he's studying AI, and see that the next pointer, Michael is pointing to Pascal, while Pascal is pointing to where? To John. And John is pointing to what? To Noah. Okay. So look at their next pointers. Their next pointers are always pointing up backwards. See? So at that point, the head will be set to this guy, because this guy is the newest guy in the school. So this head pointer that was pointing to Pascal before will now be pointing to where? To Michael, because Michael is the new guy we just added. So this head pointer now, if I do next, you see that it is now pointing to where? To Michael, because Michael is the new guy that we just added. Now we have it in memory, right? 3 of them. Michael, Pascal, and John. So 3 of them now are in the memory, and they are pointing next to each other, right? Yes.
Attention, please.
Michael is pointing to Pascal. Pascal is pointing to John. So any question before I search for Pascal? I want to pull out Pascal details. So I will teach you guys how to do
Pascal,
that.
I have some
actually.
doubts. Okay, thank you for your
Doubts?
insight. No, it's not like it's a doubt, like confused. Like I just joined and I have been going through your code. I tend to understand.
When you say you have doubts, like you know it, but you're doubting what I'm doing. Go ahead and ask the question.
No, like I'm doubting my understanding of what I'm able to see. That's what I mean. When we are assigning this Pascal, this string to the student name, I'm trying to understand the meaning of the strd up or something. I really don't understand that line.
STR duplicate. STR duplicate is malloc plus copy. So that's what it's doing. It will do malloc of this name, and it's also copy it into that array. So that's what this one is doing. So the pointer.
Okay, the word before the bracket, is it a keyword or you defined it somewhere? No, the word before the bracket. Yes.
STR dupe. It's coming from here.
From the header file. Oh,
yes.
Okay. Oh, that's my confusion. Thank you.
Relax, let me show you guys something. So if you look at it here, It's used for duplicating or copying a string. It takes a C-style string, and simply allocates memory for it and copies the contents of that string into the memory location and returns a pointer. Okay, that's what it does. STR duplicates. So, like I said, it is if you compute the length, allocate memory, copy the contents to that memory, and append the null terminator. So it is like malloc plus. So if you look at it there, it's doing a malloc actually. Okay, they did not even teach us how they build it, but it's fine. So it does a malloc. That's what it's doing. Two malloc plus STR copy together. So yeah, duplicates. That's what it's doing. This is my code. Wait, I thought I disappeared. Yes, my beautiful code. Okay, yeah. So that's it here. Okay.
Yeah,
So we have
Mr.
3
Pascal, thank you
students.
so much. Thanks for the insight. I'll leave you guys so to go to bed.
No problem. I'll be wrapping up very soon. I just want to do a little give some ideas to it. So yeah. But we're still here though for now. We're still here. Let's just grab
Okay.
the concept because tomorrow is Monday, right? You guys will
Yeah.
be doing the harder part of it. So this is I thought you're the one that said, yeah, go and sleep. It's okay. Let me don't say it. Don't worry, go and sleep.
Say it.
Go and No. I mean, you said you're working, right? That you only have chance at night. So now
No.
it is
That
night.
was
You are going
it's
to
love
sleep.
that said that, not me.
Okay, it's love. Okay.
Yeah, it's love that
Good
said
night.
that. Okay.
All right. Take care.
I have
See
a
you.
question.
Okay, go ahead. Ask
All
your
right.
question. 1, 2, 3. All right.
Okay. Thank you very much,
Ask your question.
Paspi, for this broad insight. Yeah, but I'm a bit concerned
Okay.
about that string duplicate syntax. When we say duplicate, I
Yeah.
think a duplicate of something is exactly like the original, right? Yeah. So
Yeah,
now,
that's what it is.
my concern is, hence we're working with memory, and if you see from the data of John, is consuming about not the same number of bytes. John and his course do not have the same number of bytes. So now if you
Sure.
if malloc duplicates that same memory for the next student's data, and maybe that student's data is not as much as maybe the bytes for his name and his course is not as much as that we duplicated from John, will it not cause memory leakage?
Let me explain something to you. This STR dupe and this STR dupe, they are two different things. They're not together. They're on their own. Like they behave independently. They're not dependent on each other. Okay? These two stand on their own. So if I do this, what it will do is it will go and count this length, and it will now use malloc it, and copy it into memory. That's what this guy is doing. That duplicate is
Yeah.
just a name. Just a
Yeah,
name.
and
Don't let that one confuse you. This one now here, you do the same thing. To go and count how many software engineering is, to count it, malloc, do a malloc, copy this thing
okay.
into that space. That's malloc. That's what it does. Simple. Yeah. So
well.
that's what it does. That's what you see when you see this one.
Okay,
It's like
so
a
now
space.
when you allocate
When you
a
see this one
memory
too.
for a particular student, say John, okay, say Pascal in the second for the second student, would it come and count? Will there be will the malloc have knowledge of that student Pascal before allocating the memory, or will duplicate the memory from John using the
Actually,
string
the
do?
malloc is already in this function. You can't see it. It's within the function. It has been built within. I can write my own SQL duplicates. I can write my own if I want to write my own.
Okay, so
So
what
the
you're saying
malloc
is
is actually
before it allocates memory to this Pascal now that we're just trying to create, or the last one, Michael,
yes.
before it
Yes.
memory must have counted Pascal's
Yes, it has counted this Pascal already. Yes, it has counted it. The function has all those things inside of it,
okay.
built inside.
So now,
It will
so now
count
what?
it.
So if that's the case, what are we duplicating? What are we using the duplicate for? What are we duplicating?
And we are just creating a space in memory, and we are storing Pascal inside that space. And this pointer here will point to that space. That means that space belongs to me. It belongs to my name. If you look at it here, name here is a pointer. It points to that space that duplicate created. And this space belongs to John. This is for John's struct. This is for Pascal's struct. This name here is pointing to Pascal. This is for Pascal's struct. And this is for Michael's struct. This name here is pointing to Michael. So this Michael is for Michael's struct. Okay? All right? So that's the way it behaves. So that's it. Just like the course.
All right.
This course is a pointer to the course for John, sorry. That is software engineering. Look at this one as well. This course as well is pointing to this data science. That means so anything that happens within this struct belongs to that struct. So if you look at it, the name here is pointing to Pascal. The age is 19 years. His course is pointing to data science, like that. And his next is pointing up. Okay. So that's the thing. It's not hard. So guys, any other question? Any other question? Okay. So I want to go and search for John. And I want to print John's name, age, course. In fact, his age, name, and course. I want to search for him and print it. So guys, watch how I'm going to achieve that. Now let's say we have built almost 1,000 students, let's say, though it's not going to be like this though. ALX method is not like this. Like, I'm just doing it this way for your sake. So yeah, I won't be doing all these things, but I want to do it the harder way, like the faster way. You understand? So now I have 3 students. This is John. And this is Michael. Who can tell me who is the first student in the list among these 3 students? Apart from Michael, please. Michael, don't answer, please. Who can tell me who is the first student in this list? The first.
Mike.
And who is the last? Who is the last student?
Michael is the first.
Good.
John is the last. John.
Good. So who is the head?
Michael.
Correct. I like the answer. This is it. So I want to get this John's information. I want to search for John. So this is how I'm going to do it. I will use a loop. I will look from this Michael. From Michael, I will check. Is this Michael? No. I'm sorry. I'm looking for John. So I will start from Michael. Is Michael John? No, it's not John. I will move to the next person, which is what? Pascal. So is Pascal John? No, it's not John. I'll move to the next person. I will check. Oh, John, is it John? Oh, yes, John is John. Okay, I found John. So I want to I don't know, like I'm somebody who just came to the school new. I asked John, what's your age? Tell me your course. John said he won't tell me. Okay, I went to the application. I said, okay, don't worry. Since you don't tell me everything, I will come here and search and I'll get it myself, right? Already you built the application already, but I just want to show you guys, just give you guys the flow, like how it is in real life. I will come and use a loop and I will look from this first man here, the first student here, till I find John, because it's from here. That's why you have to keep a track of the first student so that you can be able to search for all other students in the list. So without this first Without this head, you can't know the first student. And if you don't know the first student, you can't know the rest of the students. So that's it. So while, sorry guys, sorry for the noise. Uh, oh, this one staying again. Oh no. Don't worry guys, let me just copy this. Stay again, and again. Let me copy it. Say from me. Okay. So I'll use a while loop. I'm going to while this guy here, this head, right? I'm going to while it, like I'm going to transverse it. So while head is not null. Who is that person?
Yo.
This guy is mute whoever is talking to. Why some people come here, don't mute them. They don't mute them stuff. So I'm going to move this pointer from here back to the back, right? So yeah, we're going to find, starting from the head, I want to transverse. The way you transverse is get the head first, the first guy, then transverse it, right? So transversing it is like this. This is the way to write it. Head is equal to head to, right, to next. That's how to transverse. Every time you are going next, you're updating the head and you're moving. The loop is repeating itself and searching for John. So to search for John, you say if STL we want to compare the names now, right? If this head name is name, right? Compare the name of each of those data there. If John, if it's John, then print and STL returns 0 once it finds the matching string, right? So I want to print this information now, right? So I'll print it, print F. So I'm going to print his name. Name is equal to something slash n, and its age is equal to something, right? As D, and his cost or to something, right? As S, right? Yes. Name, age, cost, and what's missing? That's all. All right, that's all right. So, comma. His name is what? His name is the name. Age is what? To each. His cost is what? Cost. Very simple. And that's it. So name is this, age is this, cost is this. Then we put the arguments as printf now. So when we find it, once we get John, we want to get his information. So we are doing transversing by doing this head equals to head to next. So every time this next is next thing, it's next thing, it's next thing, it keeps going to the next name, right? So watch guys, watch how it's gonna work. Watch, please pay attention, everyone. So let's move now. Let's give it a shout out and see how it's gonna work. See how it's gonna find John on the list. Even though John was in the 100 number, maybe 200 position in that list, that my transversal will get it and we fetch him out and fetch those information. So let's just move. So malloc will create John, creates Pascal, then creates Michael, right? Yes. So we have the three of them set. So don't forget that we have 3 students. 1, 2, 3. So the head is pointing to where? Like Mario said, the head is pointing to Michael. So that's the first data in the list. So now my transversal is going to start now. So why head is not null? Head is not null now. So we go next. So it's going to compare. What's the head is Michael. Is Michael equals to Pascal? No, he's not. It's going to skip that guy. So it's going to what next? It's going to what next? Now look at the head. Just watch this head now. Guys, watch this head. This head you're seeing here. It will move from pointing here to point to this place. Now see. Next. You see? It's now pointing here now. Now this head now has moved to where? To this Pascal here, right? So it's going to transverse again. It's going to check. The name is it's John. No, it's not John. It's going to skip it. Skip, right? So now the head is now pointing to where? It's now pointing to this place here now. If you look at it, so it has now found it. That's found it. So when I go next, and I hit it, okay. Oh, it didn't print anything. Something's wrong. Who can tell me what's wrong here? It didn't print anything. Okay, I guess this is John, capital J, right? Maybe that was why. Yeah, exactly. That's a mistake. So it's capital J, not small letter J. All right, let's just do it properly. So that's I will put this guy in here. So let's do it again. So I don't want to waste time, okay? I'll just go fast so you can see how it works. All right, so let's just go now. So next. So it's going to create the 3 nodes, and while it's the head pointer will change, it's going to change again. See, now pointing here. So we have gotten John. So yes, we found John. It's going to print all those information, and there you go. So we have his name is John, his age is 12, and his course is this. Let me reduce this thing. Sorry. So guys, I'm sorry about that. So this is his name, that's his age. So even though John was in the maybe we had almost 5,000 students in memory. By the time I write a program like this to transverse it, it will transverse from the head, going next, searching for it, moving to the next node, next node, next node. And by the time it compares this is STR compares this name of that current node with John. If it finds the matching piece, it's going to print the information of John. Any question, please? Any question? Do you see how the head pointer was transversing? The head pointer was pointing to this guy before, but it moved next, it pointed to this guy. Then it moved next again, now pointed to this guy. So if you look at the head pointer now, it's actually pointing here now. So it has gotten John because this is John. So when he found John, he printed John's age, his name, and his course all together because I can find everything in his struct. Everything is embedded in John's struct, so I can be able to pull out this information. So you see the beauty about linked lists. Array you can't do such things in array. It's not possible. That's the power of linked lists. You can build a full student's data and replicate it for the whole students in your school and have them in memory. You can pull them out anytime you want to pull them out. As simple as that. Okay, so that's the while loop for transversal. So any questions so far? I don't want to go too deep. Okay, I don't want to go too deep. I want to go too deep. If I go deeper, I might confuse a lot of people here. I'm scared to go deep. So guys, if you understand this.
Okay, sir. Okay, sir. Okay.
I have a question.
So,
okay, you like you said, does it mean that we cannot use array to like transverse through an array to get
Let me
the
ask you a
person whose name
question
is
as well. Can you use an array to build something like this? An array that will contain each of this information as itself. Like the array now, we have name, age, course, and also have for each student, each of them. If you have 500 students, that array, each array will contain this information.